Well, here's a chance to test yourself, the probability practice test. There are 11 questions, 55 minutes work for 55 marks. The IB allocate 1 mark per minute. Put your name on the top, and what I'm going to do is I'm going to show you the questions, pause the presentation, check your answers, and then go forward with the presentation. I'll go through all the solutions and the mark scheme. So here's the first question, question 1. Question 2, question 3, question 4, question 5, question 6, question 7, question 8, part A, part B. Might have to scroll back and look at the original diagram again, part C, question 9, question 10. Just come back a bit. There, question 10. And the last one, question 11, fairly big question. Read it carefully. A, B and C. And that's it. So pause the presentation, check your answers, and then mark it. I'm going to go back up now and do all the problems so you can see them. Okay, so coming back up now, right up to the top. Here we go. 2 ordinary 6-sided dice are rolled and the total score is noted. Probably getting a 6 on the first one is 1 in 6. Not a 6 is 5 in 6. Second one, 1 in 6, 5 in 6. 1 in 6, 5 in 6. Okay, on the second one. Okay, what are the outcomes? So there's 1 mark. No, there's 2 marks for the probabilities. Minus 1 each error. So don't make too many errors. There go the 2 marks. This would be a 6 and a 6. 6, not a 6, not a 6, 6, and not a 6, and not a 6. So there's 2 marks for each of those, minus 1 for each error. And then we want the probabilities, probably getting 1 or more 6s. So 1 or more, that's this one, or this one. And you could say that's 1 6 by 1 6 for 2 6s, plus a 6 by not a 6, plus not a 6 by a 6. And if you do all that, I think you get 11 on 36. Or you could say 1 minus the probability of no 6s. So that's just this one. That's 1 minus 5 on 6 by 5 on 6, which is again 11 on 36. Okay, so there are 2 marks for that. I'm not going to use the technical mark scheme from the IB, method marks, answer marks, but some of these would be method marks. Okay, and reasoning marks as well later on. Let's look at question 2, Venn diagram now. It says shade the complement of the union, that's outside the union. So the union is everything in these 2 here. So outside that, this would be the complement of the union, not in the union. So for that shading, there is 1 mark. Number in the intersection, well, let's work it out. Number in A is 11, number in B is 6, outside here is 21. What's the total? 21 plus 11 plus 6 is 38. But hang on, there are only 36. So the 2 extra must have been in the intersection there. Okay, so the number in the intersection is 2. Because you've counted the intersection as part of both A and B. What's the probability of the intersection? It'll be 2 out of the total, which is 36, or 1 on 18. So there's 1 mark for each of those parts. Okay, explain why events A and B are not mutually exclusive. Because A intersection B exists. N of A intersection B equals 2. That is, A and B can occur together. So they don't exclude each other. Okay? So any of those, or either of those two reasons there. So that's 1 mark as well, making a total of 4 for that question. Mark your work. Let's move on. Question 3. A bag contains 10 red balls, 10 green balls and 6 white balls. 2 balls are thrown at random without replacement. What's that? Underline that. What's the probability of different colours? Probability of different colours. Okay, 2 balls, so that is 1 minus the probability, I guess, of the same colour. Okay, I think that would be the way to go. So here, because you've got different combinations otherwise, 1 minus the probability of same colour, which is 1 minus red and a red, is what? 10 on 26 times 9 on 25, we didn't replace it. 2 greens, the same number of greens, 10 on 26 by 9 on 25, and 2 whites, 6 on 25 and on 26 and 5 on 25. Now in paper 1 we'd leave it like that, probably wouldn't go into the multiplication, but I think it comes to 1 take 90 plus 90 plus 30 over, to do that multiplication of 26 by 25, it's 650, so it's 1 minus 210 on 650, which is 440 on 650, or 44 on 65. Now we won't go for the simplification here, so 1 mark for some breakdown of what's going on, 1 mark for some correct probabilities in there, and 1 mark for doing some sort of simplification there. Okay, count them up. How are you going? Hope you're getting some marks there. Let's go down to the 2-digit number. Here we are, 2-digit number between 10 and 99. Take them away. 99 take 10 is 89. Include the ends. That's a total of 90 numbers, if you like to think of it that way. There are 90 numbers between 10 and 99. What's a multiple of 10? 10, 20, 30, 40, 50, 60, 70, 80, 90. So there are actually 10 of them there. Okay, so, 9 of them there. So here we've got probability is 9 out of 90, or 1/10. A multiple of 10 or a multiple of 15. That's a probability of multiple of 10 or multiple of 15 is the probability of multiple of 10 plus a probability of multiple of 15 minus any that both occurred together, 10 and 15. So how many multiples of 10? 9 out of 90. Multiples of 15, what are they? 15, 30, 45, 60, 75, 90. So there are 6 multiples of 15. Now you've got to take away the ones that are in both 30, 60 and 90, because you've counted them up here already, and so, well, that's in down here. So we take away 3 out of 90, so we get 12 on 90, which we could call 2 on 15, I guess. Okay, so let's have a look at the marks for each of these now. The multiple of 10, I'll give 2 marks for that, some method mark, and then the answer. But if you get the answer, you get 2. And here, we'll give 2 here also. 1 mark for breaking it down somehow, and then for the probabilities in here, making again another 2. Okay, let's move on. Let's have a look at question 5. Okay. A box contains 22 red apples and 3 green apples, total of 25 apples. No replacement, and we're drawing 3 apples. Probability here, the first 2 apples are green, what's probably the third apple is green? So 3rd green, given that first 2 are green. What's the rule? Probability of A given B is probability that both occur divided by the probability of B. So, what's both occur? First two apples are green and the third apple is green. That's a probability all green divided by the probability first two are green. Okay, all green is what? 3 on 25 by 1 less, didn't put it back. 2 on 24 by 1 on 23. All over, probably the first two are green. 3 on 25 by 2 on 24, and the last one can be anything. So overall it is 1 on 23, which you could have worked out just from sussing it out, I guess. Okay, so we'll have, what have we got here? For 3 marks, 1 for some showing you've got some rule, and then for the breakdown in probabilities, and then for the answer. What's the probability that exactly 2 of the 3 apples are red? That's a probability of red, red, green, or red, green, red, or green, red, red. So, let's do that. It's 22 on 25 by 21 on 24 by 3 on 23. That's the first one. Or red, green, red. 22 on 25 by 3 on 24 by 21 on 23. And then the last one, green, red, red. 3 on 25 by 22 on 24 by 21 on 23. Same thing again. So it's actually 3 lots of that product, and we'll leave it at that. Won't bother simplifying that. So 1 for showing that you can break it down, 1 for these probabilities, and 1 for grouping them up. Something like that for those 3 marks. Okay, let's have a look at question 6. Here's question 6, and we've got calculate the value of A in section B if the union is 6/11. So you know the rule, the probability of the union, looking in the information book, probability of A plus probability of B minus the probability of the intersection. So let's put it in. This is 6/11, and that equals 3/11 plus 4/11, take probability of the intersection. So if you take these 7/11 from both sides, get neg 1/11 equals neg probability of the intersection. So the intersection is 1/11. 1/11 there. So we're giving 3 marks for that. 1 for showing in some way you've used the rule. So this line here is what would do, and then 1 for the answer. So a total of 3 there. Let's have a look at the second part. Find the value of A intersection B if events A and B are independent. Now that's a different rule. If they are independent, then we know you don't have to adjust anything, and it's just times probability of A times probability of B. Okay, so that's 3/11 times 4/11, which is 12 over 121. Okay, let's go on and have a look at the next one, and there's question 7 here. We've chopped it off. Hang on, I've chopped it off here. So, consider events A and B where they're not 0 and they're not 1, the probabilities. Now, the probability of A given B is equal to the probability of A. So you don't have to adjust A given that B occurs. So that means they are independent. Just 1 mark there for that. Because remember the rule for independence is probability of the intersection is not adjusted. It's a product of the 2 probabilities. But that means this would not have to be adjusted to be equal to probability of A. The probability of the intersection is 0, means you can't have it. There's no intersection, so they are separate, which is our definition of mutually exclusive. I should have just put I there and M here. That's all that's required, because it could be scanned for marking. Probability of the intersection down here is the probability of A, means really that A is contained completely within B. So that would be, we can't say anything about the independence there or whatever, so it's neither, N. So that's 1 mark for that. Okay, let's go on. What are we up to? 7, a few more to go. Hope you're getting some marks there. Here's question 8. And we'll just leave it there for the minute. Now calculate the values of A, B and C. Let's look at it. We've got a total of 88. Oops, hang on. 32 study economics. That's there. 28 study history. And 39 don't study any subject. Okay, so let's do a total. 32 plus 28 plus 39 is, what's that? I think that's a total of, what is that? 65, 104. Is that right? 104 there. So here we've got 104. We better take that away from the take 88 away from that. And if you do that, what do we get? 88. Well, let's do it. 88. We've got 32, 28, that's right. And 50, 60. No, hang on, I've made a mistake here. 60, that's 99. Okay, so we've got 99 students there, and they're only supposed to be 88. So there are 11 too many. Where'd they come from? That must have been B, counting them together there. So 11 there means in A, take the 11 off, is 21. Take the 11 off here is 17. So our values are A is 21, B is 11, and C is equal to 17. Always adding up all the groups and finding how much they exceed the total to get this intersection. All right, so we've got the values A, B and C. Let's look down here at the next question. I've gone too far here. In part B, calculate probably he studies both economics and history. That's the intersection of the two, which is 11 out of 88, which is 1 out of 8, and that's 1 mark. Okay, hang on, did I put a mark on this up back here? Oh, I think that's 1 mark each for A, B and C. Yep, 1 mark each for that. Okay, given that he studies economics, probably he does not study history. That's a probability not history given economics. Okay, from a Venn diagram, it might be best to say not history given at economics. So he's in the economics group here, but he doesn't study history. Okay, so what is that then? It's this 21, isn't it? So we can go straight there and put 21 out of 88. I wouldn't bother using the conditional probability rule. A group of 3 students is selected at random. Calculate the probability none of these students studies economics. Okay, so where are the students who don't study economics? Let's go and have a look if we choose them at random. So the first one, the probability not economics and not economics and not economics. How many have we got to start with here? Not economics, go back up here. What is there? 56. All right, these here, 17 and those, don't study economics. So if we chose the first one, would be 56 out of 88, and then there would be 55 left out of 87, and then 54 out of 86. Okay, so there, 2 marks for that answer. Don't worry about simplifying it. Oh, hang on, I've messed this up here, haven't I? I haven't put the mark scheme up here. This is 1 as well. I think we're only giving 1 for that as well. Okay, so here there's 2 for that none of these students study economics. Okay, calculate the probability that at least one of these students studies economics. Okay, the probability at least one equals 1 minus the probability of none, so it's 1 minus this answer from part 1. Okay, so just anything there. If you didn't get part I correct, then you can still get this one right. So there are 2 marks for the idea of 1 minus none and then that. Probably at least one of these students studies economics. All right, let's go down and have a look at the next question, the painter question. 2 tins are chosen at random. Calculate probably that both tins are the same colour. So probability that both are the same equals the probability of red and red, or yellow and yellow. Okay, both are the same. So this is 7 out of 12 and then 6 out of 11. If you choose them, you have to reduce the total because your hands picked up one. Even if you pick them up at the same time, you can't still be out of 12. Okay, so yellow is 5 on 12 by 4 on 11. So that's it, they're the same colour. So this is 42 on 132 plus 20 on 132, which is, what is that, 62 on 132, and you could break that down to 31 on 66, but we're not worried about that. So some mark there, 1 mark there for the breakdown and 1 for the probabilities. Don't worry about simplifying. Let's go down to question 10 now. Question 10, a fairly long one there, and we've got A and B here. Calculate probably A intersection B. Oh, similar question to before. A union B is the probability of A plus the probability of B minus the probability of the intersection. Okay, so it's 7/8 equals a half plus 3/4 minus the intersection. So if you do that, change them all to 8s. What's this? 4/8 and 6/8, it's 10/8, so it's neg 3/8 equals neg probability of the intersection. So the intersection probability is 3/8. Okay, so 1 for each of those ideas. Okay, 1 for the answer. Calculate the probability of A given that B. Probability A given B by definition is A intersection B over the probability of B, which is, the intersection is 3/8 over 3/4, and 3/8 multiplied by 4 over 3, so it's going to be a half. So 1 for showing some that you can use some rule, and 1 for the answer there. Okay, let's have a look at are the events A and B independent? Right, probability of the intersection we calculated separately as 3/8. What's the probability of A times probability of B? That's the independent rule. So it's a half times 3/4, which is also 3/8. Therefore, P of A intersection B is P of A times P of B, and therefore A and B are independent. You must mention this rule here now. Okay, I must mention that rule to say they're independent. So check out the thing and then state whether they are, giving the reason. Check out that product of probabilities. Must have both of those there. Okay, so let's go to question 11, trying to get through this so that it doesn't take all your time. So here, looking at this, the probability of B on this spinner, here we are, we've got a 120-degree chance out of 360, so that's 120 over 360, which is a third. So there'd only be 1 mark for that. Let's go down here now, there's only 3 for this question. Probability of S, so that's 210 degrees, because S is the shaded region. 90 plus 210, 210, 90 plus 30, 210 out of 360, or 7/12 if you want to cancel it down. Either of those answers is 1. Now the probability of A, given that S has occurred, what's the probability that it's in A given that S? So that's a probability of A intersection S over the probability of S. And the intersection, just looking at it back up here, the intersection of A and S is A itself here, so because it's contained within S, and so this is a quarter. Probability of A and S, A intersection S, and let's just check that now. We want A to occur and S to occur. Oops, that's not right. That's the probability of S, so that's 7/12 divided by probability of S. Hang on, I think I've just confused that now. Probably A given S should be, no, I've got that wrong. A has to occur and S has to occur over the probability of S, and that's got to be a quarter. A quarter. Let's just check this. Let's go back up. I'm losing the numbers here. So here we want the probability of A given that S occurs. So what is that? That's going to be 90 out of 210, isn't it? Yeah, 90 out of 210. Done that way because we're given the reduced sample space is S. This is how many are in S, the shaded region, and this is the probability of A given that S has occurred. So using the rules down here, it would be a quarter out of 7/12, and that's going to be 3, I'll show you here, 12 over 7, which is 3 on 7. It's done that way, the rule way. But and there'd be 3 marks for that, 1 there, 1 there, and 1 there, or just 3 for the answer if you sussed it out by going up above there in the top bit there. All right. Okay, so I was right with the quarter. A has to occur and S has to occur. All right, I've tried to hurry through that so that you've got plenty of time to then have a look back through. So go back to the beginning and see what your total is. It should be out of 55, and see how well you have done, and then check where you went wrong and go back over that. All right, I hope you've enjoyed that. Cheers for now. Let's see you in another presentation.